You ever wonder how all those tiny little parts inside your phone, or your car, or even a drone actually talk to each other? Well, it's not magic, I promise. It's more like they're all speaking a set of secret languages, and today we're going to decode them.
I mean, just imagine for a second if you tried to connect every single part directly to the main brain, the microcontroller. You'd get this, a complete and total nightmare of wires. It's a chaotic mess and, yeah, it's just not going to work. So, how do we actually fix this?
Right? How do you turn that tangled chaos into a nice, orderly conversation? Well, that's where protocols come in. You can think of them as the rules of the road, or a special language that lets all these different parts chat with each other using just a handful of shared wires.
All right, so first up is one of the oldest and honestly the simplest ones out there, UART. The easiest way to think about it, it's just a direct, old-school phone call.
It is literally a one-to-one conversation. You got two devices talking directly to each other on a private line. No one else can listen in, there are no interruptions, super, super simple.
And the real beauty of UART is just how simple it is. It only needs two wires, one for transmitting data, we call that TX, and one for receiving data, or RX. It's like one device's mouth is connected directly to the other one's ear. It's also asynchronous, which is just a fancy way of saying they don't share a heartbeat or a clock signal. They just agree beforehand on how fast they're going to talk, and that's that.
So where do you actually see this stuff? Well, UART is perfect for those simple one-on-one jobs. You know, like getting data from a GPS module, connecting to a Bluetooth device, or even just eavesdropping on your project to see what it's thinking.
Okay, but that's a one-on-one chat. What happens when you need a bunch of things to talk? Well, then you move from a phone call to something more like a classroom. Let's talk about I2C.
So picture this. You've got one teacher, we call that the master, and a whole room full of students or slaves. The teacher can talk to any student it wants, whenever it wants. But it doesn't have to shout. It just calls out their unique name, which is their special address.
And here's the real magic, the game changer with I2C. While UART needed two wires for just two devices, I2C can connect dozens of devices using the exact same two wires. Just two, one for data, the SDA line, and one for that clock, the SCL line. Talk about efficient.
And that's why you see I2C absolutely everywhere. It's the champion for projects that have a ton of sensors but don't need blazing fast speed. We're talking temperature sensors, accelerometers for sensing motion, and all those cool little OLED screens you see on DIY projects.
Now, I2C is great for saving wires, but it's not exactly a speed demon. So what if you need to go fast? Really fast? Well, then it's time to call in the boss, SPI. Yeah, you can forget the whole shared classroom idea. The SPI master is like a busy boss who doesn't have time for roll call. Instead, it is a direct, private phone line to every single one of its workers, or slaves. When the boss wants to talk, it just picks up that worker's specific line and gives the order.
And why all those extra wires? For one reason and one reason only. Pure, unapologetic speed. Data can be sent and received at the exact same time on different wires, which means SPI can easily hit speeds over 10 megabits per second. It is built to move a lot of data very, very fast. So you'll find this boss managing all the high-throughput jobs. We're talking about reading and writing huge files to an SD card, or pushing all the pixels to a big, colorful, high-res screen. If it's fast and data-heavy, it's probably using SPI. So let's just recap real quick. If you need something simple and direct, that's UART. If you need to connect a whole bunch of devices and save on wires, I2C is your friend. But if you need pure, raw speed, that's SPI. But it's going to cost you a few more pins on your board.
All right, so far we've been in the clean, quiet world of a circuit board. But what about the real world? You know, the noisy, chaotic world of cars and factories. For that, you need something different. You need CAN bus.
The best way to think about CAN bus is like a factory-wide intercom system. A message gets broadcast out, and everybody hears it. But the workers are trained to only pay attention and act on the messages that are actually meant for them. It's designed to cut through all the background noise and deliver critical commands no matter what.
But what really makes CAN so special is just how ridiculously reliable it is. It uses this really clever two-wire system that's amazing at ignoring electrical noise, and it has built-in error checking, so it basically double-checks every single message to make sure it's perfect. When a message absolutely positively has to get through, you use CAN.
And that's exactly why CAN is the undisputed king in any system where failure is just not an option. It's basically the entire nervous system of your car, connecting your engine, your brakes, your airbags. You'll also find it in heavy industry, advanced robotics, and life-or-death medical equipment.
Okay, so we've met the direct phone call, the classroom, the boss, and the factory intercom. That's a lot of options. So how in the world do you pick the right one for your project?
Well, that actually boils down to one really simple question. What kind of conversation does your project need to have? Is it just a quick, private chat? Is it a lecture to a whole group? A massive, high-speed data dump? Or a safety-critical command that cannot fail?
Once you know that, the choice becomes pretty obvious, right? For a simple one-to-one link like a GPS module, use UART. Connecting a dozen sensors? I2C is going to be your best friend. Driving a big, fast, colorful screen? That's a job for SPI. And building a robot or a car where mistakes are costly, you absolutely need the reliability of CAN.
So just remember this. The best protocol isn't always the fastest one. It's about choosing the right type of conversation for the job you're trying to do. So what kind of conversation is your next project going to have?